Alright, so this is a problem involving distance, time, and speed. And it says in the figure there's going to be a speaker, which is the source of a sound wave. That's this right here. And it's located at the origin of a coordinate system. There will be a microphone located a distance d1 away from that speaker. That's this here, d1. And there's also a second microphone located over here at a distance d2 away from the source. Now it tells us that sound from the speaker reaches the second microphone after the first. And this is because the speed of sound in air is constant. So if the wave were to travel outward toward that microphone, then by the time it got to that microphone, it would only have got about that far of the way toward the second microphone because it's going to travel radially outward in a spherical pattern. So it has longer to go in order to reach the second microphone. Now they tell us the difference is going to be delta t equals 2.48 milliseconds, which is 0.00248 seconds if you convert it. And we want to determine the distances that the microphones must be at. Alright, so let's figure that it takes a time t to get from the speaker to the microphone. And it would take a time t to get from the speaker to this point right here as well. Now we have the formula for speed, which I said earlier was average speed is going to be the distance divided by the time. Sometimes we'll use the letter S, some problems use the letter D though. But if we rearrange that, then we see that the distance can be the speed times the time. And it doesn't matter whether we use average speed here or just instantaneous speed because this speed is not changing. It's the speed of sound. It's constant, 343. But we want a system of equations, so let's do this. That the distance 1 will equal 343 meters per second, the speed of sound, times t. Because that's how long it takes for the wave to get from the speaker to that microphone. But when we analyze d2, things are a little different. You still have the same speed of sound, but instead of t, we'll have t plus delta t, because it has farther to go. Alright, so we can plug in a number for delta t. So it'll be 0.00248 seconds. Alright, so far we can't solve it though because we have three unknowns, t, d1, and d2. So we have to go farther and see what else we can use. They tell us the distance d between the microphones is 4.94 meters. So with that information, we should be able to use Pythagorean Theorem. So d1 squared plus d squared equals d2 squared. And we know that D is 4.94 meters. This is good because we have now 3 equations and 3 unknowns, so it is actually solvable. Now, you may be able to use an online calculator for solving systems of equations. What I might do just to make it easier, make sure that it can solve, is to take this result and just manually plug that in here first, and then take this result and plug it into here. Then the online calculator will definitely be able to solve it. So you'll have 343 times t squared, 4.94 squared, and then we want 343 meters per second, t plus 0.00248 seconds. Square that. Alright, so I'm going to plug that into online calculator. So here's an online calculator that I use often, symbolab.com it's called. So I'll just plug in. Okay, that should do it. Alright, the calculator is telling me that t is 0.04057 seconds. From there, we could go on to find the distances d1 and d2. So d1 will be 343. .9 meters. And 14.8 meters. Yeah, it checks out.